How is everyone this morning? Awesome. I will try to make it less painful because it's about compliance and how we are achieving compliance gates in Capital One. Every story has a why, how, and a start. That is Simon's magic circle, isn't it? And ours do too. And today I'm going to share with you our story in which we achieved the full potential of an engineering organization through automated and compliant deployments. And I'm Raji Chokaiyan. Thanks for the very nice introduction, Pete. I am Director of Software Engineering in Capital One. I lead cloud platform tools, and I'm very, very humbled to be here amongst this wonderful brains and developers. Thank you for this opportunity. Let's talk about why. Have you guys heard of Conway's Law? How many of you know about Conway's Law? Of course, it's a DevOps Summit, right? So I'm going to let you read it for a minute. In simpler terms, any software reflects the organizational structure that produces it. In 1968, Melvin Conway, in his thesis, talks about how organizational structure and the communication between the teams impact the software that gets produced. 5 decades later, I do have real-life example in my own space where I have 2 products. Apart from Spinnaker, my team supports 2 of the other products. One is an infrastructure provisioning tool. The other one is chaos engineering tool. Just for the record, it is not the customized version of Chaos Monkey. It's our own homegrown chaos engineering solution. So the infrastructure provisioning tool is built by the team, my own team. They are all SMEs. They knew how the infrastructure works in and out of in Capital One, how everything is laid out, the team dynamics, what is needed across the organization, they knew it. So they built this awesome tool, and it is adopted across the organization by 700 teams. In 2 years, the adoption skyrocketed. Now, 2 years later, we are looking at it because the support always grows as the adoption grows, right? And we are trying to remove the bottleneck, and we are trying to see how we can make it more pluggable, more maintainable, and refactor it. What we are finding out is it is just a very fancy monolith because the developers exactly knew how the interactions worked, what is needed. We made decisions on the behalf of our clients, and then we deployed a solution. That worked, right? That is completely used by the teams across the organization, but still it is not flexible enough. It's not pluggable enough. Now, the chaos engineering solution, we call that as a cloud detour in Capital One. It is developed by 1 team member, but 27 contributors across the organization added functionalities. The adoption is a different story, but that deserves its own talk. If you want to know more about it, please come find me. We can sit and talk about it. The solution, the end product of the chaos engineering solution is a very flexible, pluggable. If a disruption is not available that is needed by a team, they just create this cute little Lambda function and contribute it back, right? So it was such an easy solution for someone to adopt and use. Now, extending this thought process of how communication between the teams and organizational structure impact the software, extending this thought process beyond just these 2 elements means that having the right technology and talent is not just enough for the sustained success of any smart company. It has to be married with greater engineering practices. And that is why we developed a strategy and established a strategy. This strategy is called Engineering Excellence, officially called as Shoot for the Stars, led to a movement, a vision in which the focus was on reduced software development lifecycle, improved quality, improved performance, and reduced mean time to recover when the software fails. And this hyper efficiency became our North Star. Now, we established a strategy. We even have a very cool name for it, and we also know how our end goal looks like, and how do we get from here to there. 3 critical things were identified: slay the monolith. And from my discussions with many of you guys for the past day and today, this is a common problem that everyone in here is trying to solve, right? So we said any new application or any modernization of legacy application has to be built as microservice. It is easier said than done. We are still working through that. We came up with a set of definitions of what a microservice looks like in a capital One environment. And that includes the fact that each microservice should be an independently deployable unit. And the second one is automate everything. Automate everything from code to test to infrastructure and to deployment. This is a very scary thought, as we are a fintech company. That means compliance in a very bold letter. So we came up with some basic principles for automating these things, automating the stages as well. As in Capital One, we have to adhere to strict management of financial data and financial reporting. We always had rigorous internal controls when it comes to SOX, Sarbanes-Oxley, if you are familiar with it. That applies to both software delivery as well as business processes. And SOX also has very strict guidelines on software delivery, as in no one can introduce a change in production and therefore impact the financial reporting without any proper oversight, control, and audit trails. This segregation of duties gets directly translated to pipeline automation and execution. And then the third one is end-to-end ownership. That is not new to anyone in this room. It's basically operating in a DevOps model. Each individual software team, they have end-to-end ownership to the code that produced, from development to support and maintenance. Now, we have a strategy, and everyone clearly understood the value of it, but implementing this across the 5,000 plus developers in the organization in practice is no easy cake. So our engineering excellence team came up with some basic principles. And we also realized that automating everything, that second imperative, is a success for the rest of the 2 technical imperatives that we identified. So we focused on that first. That would lead us to the path for the rest of the 2 imperatives. And these basic principles became our stage gates in pipeline automation. Number 1 is source control mechanisms. That is also not new to anyone in this room. Everyone in here do this in some shape or form. We do LGTM. And the second one is secure storage of application binary. This stage gate ensures that the binary, the versioned and immutable binary, is published and promoted only through automated deployment process. No one can manually access this binary, manually change it and push it to production without any proper insight. And then quality checks. This talks about, am I meeting my code coverage? Am I passing all the functional test cases? And also, is my code performing and meeting SLO and under peak load? We are one of the biggest open source enthusiasts, and our teams, many of our teams contribute and use heavily the open source code. This stage gate ensures that the code that we use from open source community is meeting all the security standards and also licensing requirement. And the final one is, we wanted to make sure that not just the code we deploy in production is not impacting the production environment adversely, the deployment process itself is versioned. So any change to the build script has to be tested in pre-prod before it gets used in production environment. This also ensures that no one can accidentally access from pre-prod to prod and vice versa. So each of these environments are access controlled heavily. You guys with me so far? I know I'm going to blame it on compliance for such an animated presentation, so bear with me. So because of the wide variety of platforms and products that we operate in, the how part is defined. This is what we all need to meet to deploy our application to production automatically. But the what part is left up to the teams. The implementation part is left up to the team. My team has been supporting pipelines built off of Spinnaker for a while now, even before these stage gates are put in place. Our customized version of Spinnaker is called the Cloud One View, aka Co, and we have a booth over there. If you have any questions, please stop by. When this came into picture, that we have to automate all these stage gates within the pipeline, the very obvious option for us is to go with the declarative pipeline model. Before I go in there, I wanted to mention a couple of other things. When they came up with these basic principles, we came up with the concept called pre-approved releases. The idea is this: when an application team makes sure that, hey, I am meeting all these stage gates, I'm doing source control versioning, I'm meeting all these quality checks, I'm meeting all these security checks. So they collect evidences of their application and they submit those evidences to our compliance team manually. And our compliance team actually go through these evidences and they make sure that, okay, you are meeting all those standards, and then they put a stamp that you are pre-approved to release your code to production automatically. So that means automatically creating change order. As soon as I check in my code, my pipeline gets executed, and then automatically CO gets created and it gets deployed to production. Now the problem with this is this certification process was very manual, and it became a bottleneck that everyone lines up that here are my evidences, and it's all manual, and validating those evidences were also manual. Then we realized, okay, we need to automate that process as well, the compliance, the governance aspect of the pipeline execution as well, not just the quality gates. So we were looking at what are all the options available for us. We chose the managed template, managed pipeline options, and then we went with templates of Spinnaker. We also wanted this solution to be very, very simple for our developers to use. So we set some goals. One, the certified template with the immutable stages. What that means is we will certify our template with all these mandated stage gates with our compliance team. And any application that onboards onto Spinnaker and goes through this pipeline gets automatically certified. Rather than they submit those evidences separately and then they go through it, they approve it. So that process gets plugged in with our template model. Now, that also involved our compliance team automating their governance process, so they had to work on APIs. They published those APIs with us, and each stage we collected the evidence from our teams and submitted those evidences to the compliance team. That way they can approve, they can validate in each pipeline execution we are meeting all those standards and requirements. The second goal was flexible enough to add implementation. We know for sure that our stages are immutable. No one can add or remove any stage from this. That is also to make sure that we are meeting all those stage gates, right? But the implementation of it can be any n number of implementation. I can provide a build script for Java or Golang or Node.js within the same template, so that I don't have to go back and again and ask for certification. So that we wanted to make sure we need to make it flexible enough to add any implementation to an existing template. The third one, as we are big on inner sourcing, we wanted to make sure that any framework that we develop enable people to contribute back to these templates. And if you already are using Spinnaker templates, my sincere apologies for the redundant information here. As you see here, the abstract template YAML combined with the concrete implementation of stages with variable binding produces the well-known pipeline JSON file that we all are very familiar with. But we did do a couple of customizations to meet our needs. And we wanted to contribute back as well these customizations. One customization is the stage, the type of the variable stage type is made as a parameter that we can get from the developer. The second customization is instead of adding all the partials, implementations within same template file, we created each partial as a separate template file. We did it for two different reasons. One, for simplicity, we had so many stages, and adding all those stages in one file became very unreadable and unmaintainable. The second reason is if someone wants to contribute that one implementation partial back, they can do it easily without impacting any existing templates. Now, with these two easy steps, once the customer onboards, when the developer onboards, they choose their environment and they choose the implementation that they want to use within that environment, and it resulted in the end-to-end pipeline. And each stage, like for example, build stage here, it makes sure that the code is peer reviewed, and it passes all the static code checks, like it is passing the threshold of code coverage and security standards and licensing requirements. That information is collected and sent to our compliance team for their audit trails and records. Now, this is one way of doing automated deployments, and we have other Jenkins pipelines across the organization in different lines of businesses doing the very similar thing. We have started seeing a huge benefit of doing automated and compliant deployments. And what you see here is our 2017 number. The teams who do compliant automated deployment compared to the ones that don't, they tend to release more often. Their average number of deployments per month has increased by 95%. And their average number of production impacting incidents has reduced by 90%, and the mean time to recover has reduced by half over the year. Our goal is to have all of 100% of our applications go through these managed templates and automated compliant deployments. Now, I want to leave you all with one final thought. Have you guys any of you read this awesome book, Accelerate? Awesome, awesome. Yeah, this, my boss gave it to me a couple of weeks ago, so I had to read it. But I'm glad I did. It was such a wonderful book. Highly recommend it to anyone who wants to start a CI/CD, a DevOps culture. I'm not talking about technology or talent, but the culture itself. The authors of this book summarize the best practices, metrics, and principles to improve software delivery and software, any digital product experience, based on their well-documented research, years of well-documented research and statistical analysis. They found out that from their research that the software delivery improvement, performance, directly impacts the organizational performance in terms of ROI. Also, the non-commercial performances like customer satisfaction and employee satisfaction. And if you look at this graph, As the organization grows to the right, the high-performing teams tend to deploy more frequently compared to their medium and the lower performers. In fact, there is not much difference between middle level and the lower performers. What they found out is also high-performing team use right levers to accelerate their development frequency without compromising quality. And that is the key, right? In Capital One, our levers are compliance gates for automated deployment. Take a moment to think about what your levers are to accelerate your engineering excellence journey. Thank you for the opportunity.